Hello, lovely people. Welcome back once again to my channel. Today we are going to look at grade 9 geometry, and that is the geometry of lines. Geometry of lines. We have a sketch here, and they are asking us from the diagram above that we should determine the values of x and show that QR is not parallel. Before I explain this, I want to generally describe what happens when we have parallel lines. For parallel lines, we have three fundamentals that we look at, and we use this acronym of FUN to explain them. So what does FUN mean? It means that when we have two parallel lines, for the first one, if we have a parallel line here and here, or if we have a parallel line here and here, or here and here, we look at basically three conditions. If I have a parallel line here and here, FUN F represents this. It means the angle under this line will be equal to the angle under this line, or the one on top will be equal to the one on top, and we call that corresponding angles. So when we have this, we have what we call the corresponding angles. For U, we have that this plus this will be equal to 180 degrees. So in a nutshell, what we mean is that the two angles inside, we call them co-interior angles. So co-interior angles, when both of them are inside the parallel line, they will be equals to 180, or we say that they are supplementary angles. And then the last one that we have there, we have alternate angles. So if we have this angle and this angle, so long as they are in between two parallel lines, we say that they are alternate angles. We have alternate angles. And alternate angles are equal to each other. Alternate angles are equal to each other. So with the concept of FUN, we can calculate or determine the values inside any two parallel lines. Now let's use this concept to solve this question. They're asking us to determine the value of x. We should also understand one more thing that is missing here is that when we have vertically opposite angles, they are always equal to each other. So I'll start working from where I have values to come into parallel lines so that I can use one of these concepts. So from what I see here, we have, this is the point P. So P1, as it is given, and P1 will also be opposed to 3x, and we have vertically opposite angles. Vertically opposite angles are equal. Please remember, the basis of geometry is that the reasons must be given for every condition, for every statement. The reasons must be given for us to understand why you are taking a decision. Now, if this is 3x, if this is 3x that I've gotten here, so the next approach is to check between this and this. They fall inside parallel lines, and that is where we can use our U. So if they fall inside parallel lines, it means that 2x minus 40 plus 3x. Both of them will equate to 180 because they are co-interior angles. Why are they co-interior angles? Because they fall in between two parallel lines, which is AB and CD. Please, this must be mentioned. They fall in between two parallel lines, AB and CD. So we now go on and sum, collect line terms. 2x plus 3x is 5x. Now 180 plus minus 40 crossing over becomes a plus. Plus 40 becomes 220. If we divide with the coefficient, which is 5, we will have 44. So we have 44 degrees as the value of x. Now that is question A. Let's look at the second question. The second question, they are asking us to show that QR is parallel to ST. That QR is not parallel to ST. Is not. For them not to be parallel, it means they will never satisfy any of these three conditions. They will never satisfy any of these three conditions. So let's look at one. If this is parallel to this, we say that it can either be co-interior, alternate, or corresponding. We only have one value here and one value here. So we compare the both of them. If the value of x is actually 44, so we have this angle D on ID is 2 times 44 minus 40. We will ask ourselves, is it equals to